Alright, so the last video we began solving some equations that had radicals in them. We found out in class if the variable is not part of radicand, then it's unnecessary to square both sides. And in this case, the variable is x, and it's in the radicand, so we will have to square both sides. But we can't just square everything. We have to isolate the radical first. So in this example, let's subtract 1 from both sides to get the radical alone on one side of the equal sign. Now I'm going to subtract 1 from both sides, which gives me x minus 1. Now when you're squaring an entire side of the equal sign. So use parentheses to remind yourself that I'm squaring x minus 1, which means it's appearing twice. Now I'm going to square the radical first. Now radical x plus 5 times radical x plus 5 is radical x plus 5 squared. So really this is what's happening here. It's a little unnecessary to write, but it's nice to see why we're actually getting rid of the radical sign, because radical x plus 5 times radical x plus 5 is radical x plus 5 squared, which just gets rid of the radical sign. And that equals, and let's FOIL this out, x times x is x squared, x times negative 1 is negative x, negative 1 times x is another negative x, positive 1. So now we have a second degree equation. Let's put it into standard form. X plus 5 equals x squared minus 2x plus 1. Let's subtract x and subtract 5, which gives us 0 equals x squared minus 3x minus 4. So we're looking for factors of negative 4 that add to negative 3, and those factors are x minus 4 and x plus 1 still equals 0. Which gives us solutions of x equals 4 and x equals negative 1. Now we're not sure if these are solutions, so we're going to go back and check. For x equals 4, we would have had the square root of 4 plus 5 plus 1 equals 4. X plus 5 plus 1 equals x. 4 plus 5 plus 1 equals 4. The square root of 9 plus 1 equals 4. 3 plus 1 equals 4. And 4 equals 4. So 4 is a solution. Let's check negative 1. The square root of negative 1 plus 5 plus 1 equals negative 1. Well, I can already tell that I'm going to reject this solution. There's no way I could take the square root of a number, add something, and get a negative in return. But let's just show it. Radical 4 plus 1 equals negative 1. 2 plus 1 equals negative 1. 3 does not equal negative 1. So we're going to reject x equals negative 1 from our list of solutions. So our only solution here is x equals 4. So that's somewhat of a review from yesterday. Let's go over another example, and this is a higher order radical, a different index. Let's see, we had negative 10 plus the fourth root of n minus 2 equals negative 8. Now, we're going to treat this the same way. We're still going to isolate the radical. This is the radical. The index is 4, and the radicand is n minus 2. So we still have to isolate the radical. So let's add 10 to both sides. The fourth root of n minus 2 equals, and we're adding 10, so it gives us positive 2. So now going back to the radical equation. The index of this radical is 2, even though it's not written, which is why we square both sides. The index of this radical is 4. So we're going to raise these sides to the 4th power. To the 4th, to the 4th. So that just eliminates the radical sign. N minus 2 equals 2 to the 4th is 16. Add 2 to both sides. N equals 18. Let's plug in and check. 18 minus 2 is 16. The fourth root of 16 is 2. And negative 8 does indeed equal negative 8. One more example to go through. It's just a difficult square root equation. So the index is still 2 here. We have radical x plus 4 minus radical x minus 1 equals 1. Now, all of the radical equations we've worked with before now, we were able to isolate the radical. But in this case, we can't. We can add the radical to one side. We can subtract the radical to the other side. But no matter what we do, we're not going to be able to put the radical alone on one side of the equal sign because there's always going to be a 1 with it, or they're always going to be together. So what I'm going to do is I'm going to isolate one of them. I'm going to add this one to the other side. So I'm going to get radical x plus 4 equals 1 plus radical x minus 1. Now I'm going to square both sides, but remember I'm squaring the entire side of the equal sign. I know what radical x plus 4 squared is. X plus 4. And to aid in my squaring in this side, I'm going to write it out twice. Now I'm going to FOIL this side out. Bring x plus 4 down. 1 times 1 is 1. 1 times radical x minus 1. Radical x minus 1. Radical x minus 1 times 1. Another radical x minus 1. And radical x minus 1 times radical x minus 1. Just x minus 1. So now let's combine like terms wherever possible. X plus 4 equals. We have a 1 minus 1. They cancel. Plus x. Radical x minus 1. Another radical x minus 1. 2 radical x minus 1. So now we have a radical here. We can isolate this pretty easily. Let's subtract x from both sides, giving us 4 equals 2 radical x minus 1. It's still not isolated yet. We can square both sides, but don't forget you're squaring the 2 as well. Let's divide by 2 rather than worrying about squaring that number. So we're going to divide both sides by 2. 2 equals radical x minus 1. Now we can square this again. Square, square. 4 equals x minus 1. Add 1 to both sides. And x equals 5. So, yeah, we could square twice. As long as we're doing to the entire side of the equal sign, you're allowed to do whatever you want. So let's just plug in 5 just to check to see we got this right. Here's our check. Radical 5 plus 4. Whoops, not equals. It should be a minus. Minus radical 5 minus 1 equals 1. Square root of 9 is 3. Square root of 4 is 2. 3 minus 2 is 1? Yes. So we got it right. So just to review what we did here, we went back over how to solve a radical equation by isolating the radical first, squaring both sides. Squaring both sides sometimes includes FOILing. If you're working with a binomial, just remember you're squaring an entire side of the equal sign. We have to check our solutions to make sure both of them work, because if it doesn't, we need to reject solutions just like we did with rational equations. The index will tell you what exponent to put on both sides of the equal sign in order to get rid of the radical. If the index is 2, then you're going to square both sides. If the index is 3, you're going to cube both sides. If the index is 4, you're going to raise both sides to the 4th power. And if you do not have the ability of isolating a radical, isolate one of them, square both sides of the equal sign, then you only have one radical remaining. Isolate that radical, square both sides. Don't forget to check your solution.